NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. In the universe, we have no idea what it is, but we can measure it. Voyager 1, the iconic space probe launched by NASA over 4.5 decades ago, has just sent back a signal that has sent shock waves through the scientific community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery so profound that it has altered the course of its mission, turning back towards our planet. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a cosmic anomaly, or something even more unimaginable? In this gripping exploration, we will unveil these shocking revelations as Voyager 1 has just made a terrifying discovery that made it suddenly turn back towards Earth. The Voyager twin probes, if certain celestial events hadn't coincided, might never have left Earth. In this case, the aligning stars were the 4 largest planets in our solar system. About 60 years ago, these planets were slowly aligning in a way that had last occurred during Thomas Jefferson's presidency in the early 19th century. This rare planetary alignment went largely unnoticed at first. The first person to recognize its significance was Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology back in 1965 when space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the most efficient way to send a space probe to Jupiter or even farther out to Saturn, Uranus, or Neptune. Using a simple pencil, he meticulously plotted the orbital paths of these giant planets and made a fascinating discovery. In the late 1970s and early 1980s, all 4 planets would align in a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau calculated that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only occurred once every 176 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built 2 spacecraft to make the journey. These spacecraft, Voyager 1 and Voyager 2, were sent on an incredible mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Voyager twin probes on September 5, 1977, marked something truly incredible happening at Cape Canaveral in Florida. Voyager 1 embarked on its epic journey into space, lifted off by a mighty rocket known as Titan 3E or Centaur just 15 days after Voyager 2 was launched on August 20, 1977. Voyager 1 joined the cosmic adventure, beginning its voyage into the vast universe by following a shorter trajectory. Their primary mission was to explore the massive gas giants in our solar system, such as Jupiter and Saturn, along with their numerous moons. However, these intrepid space travelers surpassed all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke numerous records on their inspiring odyssey, even venturing into a region known as interstellar space, a completely uncharted territory within our galaxy. These trailblazing spacecraft, Voyager 1 and Voyager 2, are now more than 12 billion miles away from us. Despite their immense distance, they continue to astonish scientists with the remarkable discoveries they make out there. Most recently, they have made a discovery so unexpected that it has taken everyone by surprise. The Voyager twin probes have achieved some truly remarkable feats. Over 40 years ago, they scrutinized the moons of Jupiter and Saturn, which were initially believed to be dull and pockmarked like our moon. These moons turned out to be vibrant hubs of activity. Voyager 2 made history by becoming the first of the twins to swing by Uranus in 1986 and, just 3 years later, zipped past Neptune, a feat unmatched by any other spacecraft. As these spacecraft continue their incredible journey, NASA employed some clever strategies to ensure they remain operational. They've deactivated non-essential components such as spare parts and heaters to conserve power. This strategy aims to keep the spacecraft running smoothly until at least 2030. For the dedicated scientists and engineers who have been part of this extraordinary adventure from its inception, it's a bittersweet mix of emotions. Their hard work has paid off, And just when they thought the Voyager missions were nearing their end, a stunning discovery emerged from the depths of outer space. Voyager's Discovery data transmission and discovery in the early days of their incredible journey, decades ago, amazed researchers by providing the first up-close views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily pockmarked like our own moon, turned out to be vibrant worlds. Voyager 1 reached Jupiter in March 1979, just 546 days after its launch. Voyager 2, following a slightly different path, arrived in July of the same year. Both spacecraft were equipped with VidCon cameras that used filters to capture full-color images. Interestingly, they were designed to be very stable, spinning through space at a rate more than 15 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 photographs of Jupiter and its moons, each revealing new and fascinating details. For instance, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy crust estimated to be more than 60 meters thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that helped propel them towards interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying past Titan, a moon enveloped in an orange haze, and heading northward out of the plane of the planets. Voyager 2 continued its solitary journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy. Just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Voyager 2 soared about 2,800 miles above Neptune's stunning azure methane sky, it encountered the swiftest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest spots in our cosmic neighborhood, with surface temperatures plummeting to a staggering -235 degrees Celsius. The moon's icy volcanoes were another remarkable find, ejecting nitrogen gas and fine particles up to 5 miles into its atmosphere.
After Voyager 2's mesmerizing images of Neptune and its moons, both spacecraft were scheduled to power down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the grand tour technically concluding, NASA had extended the mission with hopes that the Voyagers would venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft were set to continue their journey into the unknown. Sagan persuaded NASA to let Voyager 1 take one last series of images on Valentine's Day in 1990. The spacecraft turned its cameras back toward the inner solar system and snapped 60 final shots. One of these images, famously referred to by Carl Sagan as the pale blue, captured Earth from a staggering distance of 3.8 billion miles. In the picture, Earth appears as a minuscule speck, barely visible against the vastness of space, illuminated by a faint glimmer of sunlight reflected off the camera's optics. We've learned so much about the planets and moons in our solar system. It's exciting to see how unique and fascinating each one is, even those that are farthest away. Voyager's journey beyond the heliosphere in August 2012 marked an incredible milestone by venturing beyond the heliosphere, a vast region of charged particles emitted by the Sun. Voyager 1's remarkable feat became widely known the following year when a study was published in the journal Science, sharing Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a powerful solar eruption between April 9th and May 22nd, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found just inside the heliosphere. At first glance, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers explained that the electron density at the heliosphere edge is significantly lower than at Earth's surface. Analyzing Voyager 1's data, researchers pinpointed the official departure date as August 25, 2012. This determination was not based solely on electron oscillations, but also on measurements of charged solar particles collected by the spacecraft on that significant day. Coincidentally, this was also the day that the renowned Apollo 11 astronaut Neil Armstrong passed away. On this pivotal date, Voyager 1 detected a remarkable thousand-fold decrease in solar particles and a 9% increase in galactic cosmic rays originating from outside the solar system. These findings shed light on the dynamic and ever-changing nature of our cosmic neighborhood, showcasing the vastness and complexity of space exploration. Voyager 1 reached an astonishing distance of 11.25 billion miles from the Sun, which is about 121 astronomical units. At this point, NASA's Planetary Science Division was diligently exploring the solar system using a series of methods, including flybys, orbiting, landing, roving, and returning samples. The Voyager missions, serving as the pioneers and architects of this approach, laid the foundation for future exploration. The Voyager spacecraft played a crucial role in surveying the universe and shaping our research priorities. By conducting flybys, these missions greatly enhanced the success of planetary science. The concept of gravity assist, which involves using the mass of a planet or another celestial object to change the speed and path of a spacecraft, was essential for Voyager's successful exploration of the outer planets. Scientists and astronomers, in their quest to fully understand gravity assist, made a surprising discovery about the vastness of outer space. Despite relying on gravity assist maneuvers for space navigation, the Voyager missions had another crucial element: the Deep Space Network, DSN. This element is like a cosmic telephone line that kept us connected with our intrepid Voyager probes as they ventured into the unknown. So, what exactly is the Deep Space Network? It may not be as flashy as a spaceship, but it's incredibly vital. The DSN is like a vast web of radio antennas scattered across the globe, from California to Spain to Australia. These mammoth dishes, some as wide as 70 meters, act as space megaphones, enabling us to communicate with spacecraft that are way out there. Then, what's its role in the Voyager missions? The Voyager probes, equipped with cameras and sensors, were our eyes and ears in space. To make sense of the data they sent back and to give them instructions, we needed a robust communication system, and that's where the DSN played a pivotal role. When Voyager 1, journeying to the outer reaches of our solar system, sends a message back to Earth, it's a faint signal racing incredibly fast through space. By the time it arrives on Earth, it's barely a whisper. But fear not, the DSN's colossal antennas are poised to catch that faint signal. They lock onto Voyager's whisper and transform it into usable data for scientists. The Deep Space Network isn't just about catching signals, it also sends commands. Missions like Voyager are dynamic, requiring scientists and engineers to adjust plans or give instructions to the spacecraft. These commands are sent through the DSN, traveling through space to reach Voyager. It's like having a two-way conversation between Earth and the most distant human-made objects in space. One remarkable aspect of the DSN is its constant operation 24/7, always listening for those distant signals. It's more than just a collection of antennas, it's our vital space connection. The DSN keeps the stories of the Voyager missions alive even as the spacecraft venture far beyond our solar system, exploring the uncharted territories of interstellar space. The extended journeys of the Voyager spacecraft have been filled with unexpected challenges. Voyager 1, in particular, is equipped with 3 onboard computers, including a flight data system responsible for collecting information from the spacecraft's scientific instruments. This data is then sent to Mission Control on Earth in binary code, which is a series of ones and zeros. Recently, however, Voyager 1's flight data system seems to be stuck in a loop, repeatedly sending the same pattern of ones and zeros back to Earth. This issue was first noticed on November 14th, when the spacecraft's telecommunications unit started behaving erratically. While Voyager 1 can still receive and execute commands from Mission Control, this problem means that no new scientific or engineering data is being transmitted back to Earth. NASA engineers have attempted to restart the flight data system, but so far, no usable data has been received. They are now working to identify the underlying cause of the problem before deciding on the next steps to fix it. This process could take several weeks. Interestingly, this is not the first time Voyager 1 has experienced issues with its flight data system. A similar problem occurred in 1981. However, the current problem does not seem to be related to any other glitches the spacecraft has encountered in recent years. As the Voyager probes face new challenges, the mission team is relying on manuals written decades ago for guidance. These manuals, while comprehensive, could not have predicted all the challenges the spacecraft would encounter as they continued their journey through the cosmos.
The team is taking a cautious approach, carefully considering all potential implications before sending any more commands to Voyager 1 to ensure that its operations are not unexpectedly impacted. Voyager 1 is positioned so incredibly far away that it takes a whopping 22.5 hours for signals to travel from Earth to the spacecraft, and that's not all. It takes another 45 hours for the team to receive a response. Imagine waiting almost 2 days just to hear back from a spacecraft. As the Voyager twins continue their epic journey through space, the team has had to make some tough decisions to keep them going. They've started turning off some instruments on these aging probes to save power and prolong their missions. Along the way, both spacecraft have faced unexpected problems, like a 7-month period in 2020 when Voyager 2 couldn't communicate with Earth. In a stroke of luck, the team managed to restore communication in August using a clever technique that realigned the spacecraft's antenna. While the team is hopeful about restoring the regular flow of data from Voyager 1, the real value of these missions lies in their longevity. Scientists are eager to study how particles and magnetic fields change as the probes venture farther from the heliosphere. However, this valuable dataset will be incomplete if Voyager 1 can't send information back. The team has also been innovative in finding ways to extend the power supply on both spacecraft. Despite the challenges, the Voyager missions have far surpassed their initial expectations, outlasting any other spacecraft in history. So, while the engineers are working tirelessly to keep them going, they also know that more challenges may lie ahead. Despite their dwindling power, the voyages of the spacecraft are far from over.